So let's move ahead with something known as container. Okay, and before directly jumping into container, like what is this container and all, let's try to understand some basic fundamental things that will help us to build the concept in much deeper. Okay, so say for example, at a very high level, what we are doing at in IT or any company, let's try to understand. Say this is a developer. Okay, this is oops, this is a developer. This developer is writing a piece of code, right? This is a code that is being written. This code basically, we can say that the code is based from the code is something, an app, I can say. Okay, this app must be running somewhere. Okay, it must be, the whole idea is this app must be running. Okay, whether you take any example, if it is a Netflix, if it is a Geo Hotstar, if it is Ola, it is Uber, Zomato, whatever it is, there's an application that is running somewhere, and people like you and me are consuming it, right? We will start connecting to this app, we'll start utilizing this app, and these folks, I mean the owner of the app or whatever, they will start generating revenue out of it, right? This is the whole purpose. The app must be running somewhere. Now let's try to understand what are the ways, like what are the approach we can run this particular app. The first thing is, like that sometimes we call traditional way, the way traditional way. Okay, what happens in this, like how we run an application, there is something known as hardware. Okay, this is hardware. On top of hardware, there is something known as operating system, right? There is an operating system. On top of operating system, we'll be running an app here. This is my app that is running on top of it. Okay, not bad, good. But what could be the problem here in this particular approach, or the challenges? Let's say a very simple example, the hardware has 10 GB of RAM and 10 CPU. Okay, 10 GB of RAM and 10 CPU. This is what it has. Okay, out of this 10 gig, say for example, hardware operating system will consume 2 GB of RAM and 2 CPU. Just an hypothetical situation. Okay, not always like 2 GB or 20% only. And application, say for example, consume 4 gig of RAM and 4 CPU. All right, so that's okay. But are you seeing any challenge here? Any challenge here in this approach? Yeah, the challenge here is, like not a proper utilization of resource. Okay, not, I can say, proper utilization of resources, right? We are paying for 10 gig, but we are just utilizing 60% of it, right? Just 60%. 40% we are wasting. Okay, nobody likes to do that. If I am paying for 100%, I must be utilizing 100%, or at least 80%, 90%. But this is not good. Okay, fine. If this is not good, what else we can do here? Okay, let's do one thing. Why not we go ahead and modify this approach a little bit and launch one more app on top of it. This is my application A and this is my application B. And this, just an hypothetical situation, this will also consume 4 gig of RAM and 4 CPU. Wow, good. Is the problem got solved? Yes, the problem got solved. Now we have a proper utilization. We are almost utilizing 80% of our resource. That is good. At 20% we may need for any spike or something. So this is better, I would say, a better approach. Okay. But what else? Are you seeing any other problem here? Yes, the problem is different problem here. What is the problem? Say for example, this application A belongs to say for example belongs to team A. This is team A. Okay, the owner of the application B belongs to team B, right? This is team A and this is team B. All right. Yeah, so this is basically where team A member and team B member has, I mean, what I'm trying to say, how could it be a problem? Problem of security. How somebody from team A will get an access of application A. From application A, he can get access of operating system. Yes, quite possible. From operating system, can he get access to application B? Yes, it is possible. I'm not saying it's that much easy, but it is quite possible, right? Similarly, the team B will get an application access of application B, operating system access, and they can also access the application A. It's C program files, right? Just if you keep it simple, C program files, all the applicains all there, or maybe whatever the, if you have an operating system access, you can access to any other thing. Can we make it more secure? Yes, there are ways to make it more secure, but you have to put some extra effort. Out of the box solutions are not available. You have to put some extra effort. Okay, but this is possible. This is something nobody likes it. If you are running multiple application on a same hardware in this particular way, this is going to harm you. This is not good. Okay, so if this is not good, right, what are the, let's try to understand the pros and cons of this particular approach. Okay, pros. What are the pros? I mean, the most important thing, like, if I have to design application, if I have the choice, I will always design the application like this because it's most simple. It's very simple setup. Okay, no abstraction, direct access to the hardware. And in this kind of scenario, like, this I mention as a traditional approach because this is something we used to design application like this, I would say, before the cloud era, or I mean not just before the cloud era, because before that VMware, zones and all those things already came. So I can say little maybe 20 years back or something like that. Okay, so this kind of application design is basically well suited for something known as monolith application. What is this monolith? We will go and discuss. I mean, if just as a very high level right now, it's one application. Okay, it's just one single application that runs all the business logic. Okay, just one single code that runs all the business logic. So these are the pros. What are the cons? Okay, cons. Okay, first of all, that we can say, if in this kind of approach, resource waste, right? We are wasting a lot of resources if you're just running one single application. Okay, that is one thing. What is another thing? Like, isolation. Like, even if you are going and running multiple application on top of it, poor isolation is not good. I mean, from one application A, I can access application B. So isolation is not proper. Okay, and scalability is a challenge. Scalability means what? If we want to add new apps, we have to, means like, if you want to add more application, you have to add more hardware. That is, again, it's not that much easy. Okay, so scalability is another challenge that we can say. All right, what else? Like, and there could be because isolation is not good. So there could be a challenge of environment mismatch. This guy wants some Java version, that this guy wants some different Java version, or so on and so forth, right? Environment mismatch because you are not isolating it properly. So this could be another challenge with this particular approach. All right. Okay, fine. If these are the challenge, how can we run our application? Then people started thinking about it. Okay, let's do one thing. Okay, from traditional approach or traditional way, they came up with some another solution that we called virtualization. Okay, the whole compute, I would say, why it is not moving up, just give me a second. Yeah. So this is the whole cloud computing is basically kind of based upon this virtualization. So what happens in virtualization? Let me try to explain you here. Another approach, the second approach could be virtualization. Okay, so what happens in virtualization? Okay, we have same hardware, like 10 GB of RAM. Let's say this is my 10 GB of RAM and 10 CPU. On the hardware we have something known as operating system. Okay, above the operating system there is another tiny layer, okay, very tiny layer, that we call hypervisor. Okay, and on the top of hypervisor we ran something known as virtual machine. We run virtual machine. This is virtual machine A, this is virtual machine B, this could be virtual machine C, so on and so on. Let's make only two so that the diagram will look good. This is virtual machine A, virtual machine B. But what happens in virtual machine? The virtual machine will come up with their own operating system. They have their own operating system. Okay, this is their operating system. They have the application binaries and libraries, everything get installed here. Okay, I can say the binaries, the libraries installed here, and it will run some application. It will run app inside it. Okay, this app underscore A, the same application A. Similarly, this virtual machine will have its own operating system. This virtual machine will install all the binaries, requirement, dependency of the application, and this will run application B, right? So this is how the virtual machines run. Okay, and the owner of the application A is team A. They will get access to this virtual machine. The application B owner is team B. They will get access to this virtual machine. Perfectly fine. But you may ask, like, okay, fine. You may ask here, like, how about the security, right? How about the security? Like somebody from application A will get access to the operating system, get access to the hypervisor, get access to the operating system, go back and access the application B. So this is not possible. This is not possible. You will stop here only. Okay, you won't get access to the hypervisor, and you won't get access to the operating system, you won't get access to the hardware, and so on and so forth. You won't get access to the application B. If you are running application A connecting to virtual machine A, you will only access this portion. Who will protect you? Hypervisor. Okay, application B guy for team will have only access to this portion. Okay, nothing more than that, nothing less than that. That's it. All right, and how to protect, how to use hypervisor to do all those things, that is something taken care by the system admin who is managing it. Something like your EC2 instance is something like that. Okay, this is one of your EC2 instance. Okay, this is one of your EC2 instance. You won't get access to the hardware of Amazon, right? Not possible. Whatever the base operating system they are running, we don't know what hypervisor they are using. They have published a lot of document and all, but we don't have the access to those hypervisor. This is somebody from Amazon can access it, and somebody who is an admin there can create it, and he will give access to you. You can go and create a virtual machine. This is EC2.1, EC2.2, like that. And they are security wise, the hypervisor is so strong. This virtual machine can belong to Swiggy, and this virtual machine can belong to Zomato. They are competitor, right? But they don't know, like, what. I will only assume that I am running only my virtual machine. You will only assume that I am running only my virtual machine on this hardware. We don't know what is this hardware, what is the capacity. We don't know anything. So this is as secure. Like, even a computer can come and run their machine on the same hardware, and they don't know. All right. So this is good. I'm getting some questions. Sudipta is asking, here is the operating system also tightly coupled with the hardware. You're talking about virtual machine. The answer is yes. So we are not here operating system agnostic. Hello everyone, good morning. Sorry. Okay, since network sharing is the same, that is, yeah. Abhishek, you're asking about this one, virtual machine, how the network flows and all. Yeah, I will explain you how it works and all. I'll explain you in terms of container, then you'll also understand VM. But that isolation is done by the hypervisor will allocate you a dedicated portion of hardware. This hardware, say for example, this is hard disk. A portion of hard disk will allocated to this guy. A portion of hard disk is allocated to this guy, something like that. Okay, and this portion only belongs to you. This portion only belongs to this machine. Okay, and that is all done by hypervisor. All right. Yeah. How they are isolated? This is something done by hypervisor. I mean, how part we need to go dive deep in virtualization, how hypervisor work and all. Okay, there is a way we can. If you ever worked on Linux virtualization, you will get to know that we create we separate hardware and everything based upon the VMs. That a VM will get this portion. And how part, again, as I mentioned, we'll go and dive deep in container. You will understand how part. Just give me a few minutes more. Okay. All right. So this is how kind of a container, I mean the virtual machines run. All right, that is good. Okay. So what is the challenge here? What are the pros and cons? Let's try to understand. First, pros. I mean, pros are very simple. Okay. First of all, the thing that we were not able to access there. Why the size is getting changed? It should be 25. Yep. Pros are basically, it's very simple. It's better isolation, right? Definitely, it's a better isolation. Okay, I can say it's a better isolation because of hypervisor. Okay, hypervisor isolate in such a way. It is something like, if I draw it, it is something like this. For this guy, it's something like this. They will get only this portion of hardware. These guys will get only this portion of hardware. And this base operating system is something only the admin of this hardware will have access. Okay, and your application dependency is in your operating system. You can see that you're coming with your own operating system. You are coming with your own operating system. Whatever the dependency of binaries and libraries, you can go ahead and install in this operating system. It is anyway not related to this, right? So this isolation is basically offered by the hypervisor. All right, so better isolation, and it is basically security part. Again, improved security. If I compare with the security part of the traditional approach, this is better security. Yes, it's there. And moreover, we are optimizing the hardware, right? The same hardware we are running one application on a traditional approach. On the same hardware, we are now running more than one application. So infrastructure optimization is also there. We are optimizing the infrastructure, right? So this is again one of the things that we can say as a pros. All right, what are cons? Okay, the most important cons is just try to understand how many operating system you are running in this particular setup. 1, 2, and 3, right? How many operating system you are running earlier? Only one. So your infra, if it is licensed or something, your cost will increase. You have to hire more system admin for that, right? You have to manage, you have to patch them, you have to take backup. So your kind of I can say, instead of one operating system, you have to now manage 3 operating systems, right? So that is one of the challenge, right? So it's basically, and all these virtual machine, right? It's coming up with a full operating system. This is a full operating system. This is a full operating system. So it's basically heavyweight. I can say your capex cost will increase, right? Cost is little bit higher. Second, I can say it's heavyweight. It's coming from full operating system, right? That is one of the thing. So if it is coming from full operating system, that is what do you mean by full operating system? Operating system is an operating system. What do you mean by full operating system? I'll tell you what is the meaning of full operating system. Okay, just give me a few more minutes. Okay, and it is again it's basically your cost, maintenance cost, heavyweight, all those things are the challenge. Okay, no doubt it is a better approach from the traditional way, but just just kind of a think, like, just wait a minute and think about it. I'll give you one scenario. Okay, I want to run application A, right? The whole requirement is I want to run application A. All right. For running application A, I need an operating system. Perfect. Definitely, any application you want to run, you need an operating system. Or wait a minute. Okay, if I need an operating system, let's try to understand the same thing with this. We are connected over a meeting. Let's say it's a what? It's WebEx, right? We are using WebEx, right? Zoom kind of application. In order to run WebEx on your machine, do you need printer driver? Yes or no? If you want to run WebEx, just say you just want to run WebEx on your machine. Do you need printer driver? No, I don't need a printer driver. Do you need Microsoft Office? No, I don't need Microsoft Office. Okay, do you need Adobe Acrobat Reader? No, I don't need. There may be another application. Do you need Teams to run WebEx? No, I don't need these many applications to run WebEx, right? All right. You don't need this, you don't need this, no need of this, no need of this. But what actually is required? Okay, if I have to run only WebEx, this is an application. If I have to run only WebEx, what is required? Just few things, few libraries plus binaries. That should suffice my like what is the requirement to run. Just only few libraries and binaries to run WebEx, not full operating system. This is full operating system that comes along with printer driver, XYZ driver, something that not at all require if my requirement is just run WebEx. Okay, are you getting the point? We don't need these things. These are just heavy, bulky things that my WebEx is not going to use it. So why should I install it if it is not required? This is where container comes. The concept of the container is exactly same. Okay, fine. If you want to run application A, why you need a full operating system? The operating system has XYZ driver that you are not going to use at all. Then what is the point of having it, right? So that is where, okay, fine. If I have to run a WebEx, what I can do, I can give you an environment where you come up with your code, okay, and whatever your code is required, maybe a Java version is required, or maybe a Python is required, maybe a Node is required. I'll give you those libraries plus binaries so that your code will be running. And the whole part, I will say this is a container. This is container because your code plus dependency, right? That's it. You only need your code plus dependency to run your application. That's it. Nothing more than that, nothing less than that. Anything more than that is an headache for me, because why should I, that will reduce my boot time, that will reduce my my performance of my application, that will eat my memory and CPU that I don't want. I want my memory and CPU just eat by my application, nothing more than no one else. So let's try to deploy the same thing with this particular concept. We have hardware. Okay. We have something known as base operating system. I can say the operating system, and we'll come up with container. Container will have the app plus binaries and libraries. Now tell me one thing. If I compare this particular scenario with this guy, okay, this one, if this guy is require 4 GB of a RAM and 4 CPU, probably this guy will require 1/10 or half, maybe 1 GB of a RAM and 1 CPU, isn't it? Because this is not a full-blown operating system, it's just application, binaries, and app is also there, but it's not full operating system. It's a very tiny miniature version of operating system that is nothing but my binaries and the libraries that is required to run my application. So can I run more containers on the same hardware? Yes, obviously, because your requirement is almost half or less than that. So you will run more containers in this particular form. Okay, fine. But what about security and all? That will come. But are you getting the approach? In order to get security and all, or maybe like something else, there is another layer in between, just like hypervisor, but it's not hypervisor, that we call container runtime, or sometime we call runc. Okay, this is how your container runs. So with this particular approach, we can run more. I'm just do it here 3 or 4, but just try to understand, because your hardware requirement is much lower. Then you may ask, okay, fine, all looks good. What about this? Somebody will get access like this. The same thing. Is it not possible? The answer is not possible. How part? Again, I will explain you how it is secure, how all these things has been done. That part I will explain you, but because for that I need to explain some basic concept of operating system, that the next topic is. But this is what your container is. What all consists in bandwidth, whatever is required to run your application. If your application is written in a Java, so you must need Java to run your application. Java must be installed. Maybe some other binaries and libraries. The developer will tell you like what is required to run my application. Are you getting it, Praveen? Sorry. So virtualization not uses a partial operating system. Containerization, container uses partial operating system. Okay. Randhir. Virtualization uses a full operating system. It's a container who use partial operating system. Okay, what are pros and cons? Let's try to understand. We'll understand pros and cons here, and then I will explain you. Then we'll go dive deep into the container. What actually is container? We'll with our understanding, we'll write one definition of container, and then I will tell you what actually is container, and then we'll dive deep into. Today you will get to know that the real definition of container. Okay, that is my promise. So let's talk about pros. First of all, it's lightweight, right? Obviously, it's lightweight because it's containing only few libraries and binaries. Rahul, it will automatically become clear in 10-20 minutes. Okay, what is a partial mean? Just give me 5-10 minutes more. Okay, let me complete this one. Okay, it will automatically become clear. And whatever the pros that I'm writing here, I will come back and explain you with an example. Okay, it's lightweight, it's fast startup. Okay, portability is there. The most important part of the container is portability. What do you mean by portability? Again, I will explain you. Okay, and cons, there are so many other pros. I can write it, but it's not in my high school examination that I need to write 5-pointer. Okay, it could be most important things I'm writing here. Cons could be like I can say cons wise is like sometimes, because I would say less isolation than VMs. That is one of the point that we need to understand. Okay, I can say less isolation than VM because they uses the same operating system kernel. The operating system is same. They use this guy's kernel only, and that is why the use case for the container is little different than the use case of VM. Okay, and that also we will discuss. Okay, so this is what I can say the containerization is. Okay, this is what the container is. Okay, and if I have to define a simple definition of container, what actually a container from here, if I need to define what do you mean by what is container? Okay, so the container is nothing. Okay, if I have to define container is nothing. Container is lightweight, standalone executable software unit that package code and its dependency. Okay, you can say container is nothing, code plus dependency. All right, this is what actually the container is. What you want to run a code actually and come up with all your dependency. This is what the container is. If you go back here and just try to understand from where we started, okay, fine, we need an application or basically a code that must be running. In order to run this particular code, we need this code plus some dependency. Okay, some libraries or binaries, some dependency. And if we combine these two things, this is what the container is. Actually, the ultimate goal was, from the way we started, everybody wants to run their application so that it get consumed by their end user. Okay, the application must be up and running, and in order to run an application, there are multiple approaches. Traditional way, we have a hardware, we have an operating system, we are running one application on top of it. Complete waste of resource. It's not at all good. Is it not good for all the approach? No, there are some use cases there where still we can run our application. I am running some banking application that is very, very critical for me. I will run something like this. I am running some security application that is very critical for me. I will run like this. I'm not saying it's kind of a nobody uses it. Okay, there are use cases people still uses this. Okay, and for those use cases this is one of the best approach. But for our approach, general approach, this is not going to work. And the same way, if I start running multiple application on the same hardware, there are some challenges that we have discussed. Okay, fine. The another approach is virtualization. This is good, no doubt. Still one of the best choice to run your application. But again, can we further optimize it? Yes, we can. Why? Because here you are using the full operating system. That is again making your application like slow, or maybe something that is not required. So can we do little better? This is where people start thinking about, why not let's run our application. What is actually required to run my application? App plus dependency. So just put into one kind of an isolation that application along with the dependency, I will run it. So that is why I mentioned portable. If you are running in this hardware or you are running in another hardware, if you are running on your laptop also, the container will run exactly same way. Why? Because it already contains its dependency. If you are migrating your application from this hardware to this hardware, it won't complain that Java version of this is missing. No, because that Java version is already there inside me, right? Nothing is missing. Whatever is required, I already contained it. Are you getting it? So nothing is missing what is required to run my application. There is no dependency issue. All the dependency I am carrying along with me. Okay, so that is why I am telling you the partial operating system. And those dependency, we are not saying it's a full operating system. It's a tiny operating system. It's a small operating system. Okay, but it is acting like an operating system, isn't it? Right? What operating system provide you? Operating system provide you a dependency, a layer between you and the hardware. This is what this guy is doing. All the dependency and interacting, helping you to interact with the hardware. Okay, so this is why we are saying it's like it's partial. All right, so yeah, one second.